wanted to talk about these couple of problems here at the end, 54 and 56, and what they wanted you to do with this. It says to determine which value best approximates the definite integral, make your selection on the basis of a sketch. So what you should have done on number 54 is sketch that function. So our function is 4 cosine of pi x. That would be our function. If I'm graphing that, I have to find the period of it. And the period is always going to be 2 pi divided by b. b is pi. So the period is going to be 2. So this is the way the function is going to look. For cosine x, I know that my key points goes, normally the key points for cosine go 1, 0, -1, 0, 1. But now they're going to get multiplied by this amplitude of 4. So now my key points are going to be 4, 0, -4, 0, 4. And instead of my period going from 0 to 2 pi like it normally does, it's going to go from 0 to 2. So it's going to have to be 0, 1/2, 1, 1.5, and 2. So those are going to be my points I'm plotting. At 0, I'm going to be at 4. Then at 1/2, I'm going to be at 0. And then at 1, we're at -4. And then at 1.5, we're at 0. And at 2, we're going to be up here at 4 again. And so this would be the curve that we're looking at. All right, now we were asked to find, in this problem, find the area from 0 to 1/2. So I'm going to take this, and I'm going to look at it just from 0 to 1/2. Remember, this point right here was 1/2. I'm trying to estimate this area. Well, look at the rectangle I could draw as an upper bound. This would be 1/2, and this height here would be 4. So what's the area if I just do 1/2 times 4? What do I get for the area? 2. But is the true area less than or greater than 2? Less than 2. So if I look at my options for these answers, 4, 4/3, 16, 2 pi, -6, the only one it could possibly be is letter B, because that's the only one that is below 2. Okay? So that's what they wanted you to do there. Now, I also wanted you to find the way you could find the true area on your calculator. So what we can do is we can go to y equals, we can put in 4 cosine of pi x. I need to check my mode, make sure I'm in radians. When I graph it, I need to do a zoom trig because I'm using a cosine curve. And here's the way the curve looks. I really only care about looking at it from, I'm going to change my window, from 0 to 1/2 is all I care about seeing it. I got to make this less. I'll make it 0.1. Okay, so this is the only part of the graph I'm looking at. That's from 0 to 0.5. I'm trying to find that area. So I'm going to go second, trace, calculate. If I go down to number 7 and I tell it to go from 0 to 0.5, because that's what the problem said, it's going to tell me that the exact area there that it computes is 1.27. Okay? So our calculator can find that area. Now this will just be an approximation. It will not be as exact as what you can get by using integration. Integrating finds the exact area. The calculator is finding an approximation for it. Okay? So for 56, here's our problem. I'm going to sketch the graph. The square root function, you should know, normally looks like this, but now it's going to be shifted up 1 unit. And my problem is the integral from 0 to 9 of 1 plus radical x. So if I want to graph that function, then what I can do is I can just plug in 0. Plug in 0, I get 1. Plug in 9. Well, the square root of 9 is 3 plus 1 is 4. So I know when I'm out at 9, it's up at 4, and it's got this kind of a shape to it. So this would be the area that we're trying to find. Now, if I estimate this area, what's this down here? What's that width going to be? 9. What's this height going to be? 4. So what would that area have been if I was talking about the entire area? 36. So the upper sum, if I use this whole thing, would be 36. But we're not using that. We're estimating based on the fact that it's going to have to be less than that, because I'm trying to find this area under the curve. And so to find that area, it's got to be something less than 36. The only thing less than 36 is 27, so it's going to have to be letter C. And so to find it exactly, we can go to y equals. We put in 1 plus the square root of x. Somebody get the door, please. I do a zoom 6 now. And we're trying to find the area, so we're going to go to second trace. We're going to go to calculate. We're going to go down to number 7. And we're finding it from 0 to 9. And this is what the calculator comes up with for the area, 27.00045. Okay, makes sense? All right. Any other questions on the homework at all? Yeah, Lizzie? Sure. So let's take a look at 41. Which part? Okay. I'll just kind of talk about it. So the first one says the integral from 0 to 7. Well, here's the answer for the integral from 0 to 5, it's 10, and from 5 to 7 is 3. So if I want to find the integral from 0 to 7, I would just add those up. So the answer to that would be 13. And then this one is from 5 to 0 instead of from 0 to 5. Does anybody remember what the rule is if we switch the order of those? It makes it a negative, right? It makes it the opposite. So the answer would have been 10, but now it's going to be negative 10. And then on letter C, what does this mean? If we're just we're starting at 5 and ending at 5, what's that area going to be, guys? 0. We're not moving at all. And then this one says if we're going from 0 to 5, but we're going to do 3 times the function, well, we're going to have 3 times the area. So it would be 30. Okay? Anybody else questions on the homework? All right.